Let's now tackle the second problem of recursion on strings. Specifically, let's say we want to actually write a method that's going to take a string and return its reverse. So what's really a reverse? Let's say a reverse of a string is simply itself written backwards. Let's see some example. Okay. Let's say what would be the reverse of empty string? Well, if you write an empty string backward, well, in this case, it will just be the same string, just empty. What about the reverse of a string of a single character? Well, in that case, you just write that character from right to left. In that case, it will still be the same string, right? So these are maybe the special cases that you want to handle immediately. So that will be a suggestion about how you should characterize them when you actually do the recursive solution, right? What about this one? Let's say we got a string of two characters, A, B. In that case, how do you return the reverse? Well, in that case, that'll be from right to left, BA. All right. And what about ABC? Well, from right to left, CBA. Finally, let's say you got ABCD. In that case, it will be DCBA, right? Now, how do we solve this problem here recursively? I'm pretty sure you know how to solve it iteratively using a loop, but that's not the point over here. We are trying to think about solving problems which you may have solved before or not recursively. That's really the main point about this current module. All right, so let's now, before I let you pause the video and think about your solution and sketch it out, I would suggest I give you some hints. Okay, let's take a look. So now we are solving our second problem, and just remember, when we talk about the previous problem of palindrome, we say that one way for you to actually get a strictly smaller problem is by getting rid of the first and also last characters, right? Should this apply in the case of reversal, like taking the reverse of the string? Let's see. We know that over here, in order to calculate, well, we know that this, what will be the reverse of ABCD, for example? Let's see. So the reverse over here, let me use thinner. Okay, so if I go from here to get a reverse of, so that should be DCBA. The hints I want to give to you is to really see how the input string ABCD should be related to the output string DCBA. Right? Let me give you the hints visually. I want you to break down the input string in the following way. Break it down from the first character and also the remaining string. Okay? Break it down. And based on these two decompositions of the input string, I want you to see how these two parts are actually related to the output string. So that'll be my hints for you. All right, so now you can pause the video and think about how the problem can be solved recursively. And even better, if you can sketch out your Java method solution. All right, assuming that you thought about it, let's now see. Let me follow up with my visual hints. Right? You can see I broke it down into the first character followed by the remaining part, which is quite different from how I did it for the palindrome. The way I broke down the input string is by saying the first and last character and also the middle part, right? So it doesn't need to be this way always. I'm just showing you another way of decomposing the input string. In this case, I'm decomposing by first character and then the remaining part of the string. Apparently, the remaining part of the string is a strictly smaller problem, right? Let me now annotate it right away. Okay, you can think about this part here. BCD is a strictly smaller problem, which can be solved recursively. Maybe it's a strictly smaller problem. Okay, let's now take a look at the output string. The A over here can definitely be related to the A over here at the end, right? How about this part over here? You can see DCB is not exactly DCB is not exactly BCD over here, but they're really related to each other in a very meaningful way. Do you know what it is? Well, the reverse of this strictly smaller problem is exactly over here, right? So hopefully you already see that. Let's now try to highlight this over here. So this is really the solution to the strictly smaller problem. So this is really the solution to the strictly smaller problem. Smaller problem over here. So BCD, if you take its reverse, you're actually going to get DCB. Okay, that's exactly the case. Well, so that means you just have to do some rearrangement whenever you're doing the recursive call. So you're going to recursively get the reverse of everything except for the first character, and then put it at the front for the resulting string, and then put the original first character to be the ending character for the resulting string, and then you can return this. So that'll be the idea for reverse. Hopefully you got it. All right. Let's now take a look at the slides and to see the written form of those hints. Empty string, what should be the reverse? It should be empty string. So that'll be the first base case. What about string of length 1? In that case, nothing to do. You just return just the string. And what about recursive case? So we are talking about string of the length larger than or equal to 2. In that case, what we're going to do is we're going to say the head of the string, which would be the first character. Take that. And also, you want to take the reverse of the tail of the string. So the tail will be everything except for the first character, right? And then you're going to return the concatenation of 2 and 1. 2 and 1. Especially 2 is really the recursive call to solve a strictly smaller problem, which will be the tail of the string, right? You can see this will be the tail of the string. And you want to solve it recursively to get its reverse. And then you're going to massage the solution over here and the first character over here by putting this first character to the end of the resulting string. That's really basically a combination you have to do. Remember, let me just remind you very quickly, right? If you recall this, these documented steps for solving problems recursively, you can think about we're having the tail of the string over here. This will be the reverse of the tail of the string. And then we want to somehow combine them into the solution for the original problem. So that'll be the extra combination or massaging that we have to do. That's exactly what we're doing here. I'm trying to link to what we have learned as a principle. All right. Let's now take a look at the Java code about how the reverse is going to work over here. Okay. So that'll be the Java code. Let's now go over line by line over here. So reverse of is going to return a string, taking a string as input over here. And let's talk about the base cases. In the case where it is simply empty, you're just going to return empty string. In the case where it is actually length is 1, you just return the same string. All right. Of course, you can combine these two by saying if that's either empty or 1, you just return the same string. That will be fine too. But I just want to separate them, which will also work. So this part over here is really the base cases, right? We got two base cases. So that's really the base cases over here. So base cases. And what about the recursive case? Recursive case. So this part here is really the recursive case. But we're going to see exactly how that will work, right? So this part here is the recursive case. Recursive case. Okay, let's say we are getting this particular string, let's say S, right? Let's say this is the input. Let's say that's actually larger than or equal to 2 for its length. So what's going to happen is if you think about this is string S, right? Which is conceptually an array of characters, as we said before. You're first of all, you're going to say what would be the tail. The tail will be, we're using the substring method, which will go from 1 inclusive, index 1 inclusive, and s.length exclusive, meaning that it's s.length minus 1 inclusive, right? So we are dividing the string into two parts over here. And this part over here is really the tail. This part over here is really the tail. So that will be from index 1 until s.length minus 1. So this part over here, let me just put the index over here. So starting from index 1 all the way until including s.length minus 1. Minus 1, right? So this will be last index. So this will be the index 1 over here. And this part here is really called the tail of the string. So this is the tail. And then we're going to call recursively over here. We're going to make a recursive call on something that's strictly smaller. So you can think about this part over here is really the recursive call. Recursive call to solve a strictly smaller problem. Okay, the strictly smaller problem is exactly the tail over here, right? You can see compared with the original string, this tail over here is strictly smaller because we have gotten rid of the first character, the head of the string. And what about the head? In the case of the head, it will simply just be using the character at index 0. So this will be the head over here, right? And how do we construct the ultimate solution? So what we're going to do is, so this part here is the input, right? So you can think about the output is going to look like something like this. The output that we're going to return is going to be very similar to, it's going to be a string of the same length as the input for sure. But what's going to happen is, this part over here, the head, is going to go to the end of the resulting string. This part over here is going to go to the end over here, right? So this part over here will just be the end, so that will be as the length minus 1 position, right? And this part over here is not just the tail, but it's going to be the reverse of the tail. That's something for you to notice, right? You can think about this part over here. Indeed, it is the tail, but we're still going to call the reverse of on the tail. So this will be the reverse of the tail. And then in that case, it's simply just going to work, right? So notice that this part over here and this part over here is really related to by calling the recursive call reverse of over here. All right. Let's now trace one input together. Okay. Let's use the ABCD example. Okay. So let's say we say reverse of, let's say ABCD. Again, I'm not using the double quote just for simplicity. Okay. In order to do this, we have to see how to break down the string. This is the first character, right? That's the head, and this part here is the tail, right? So what's going to happen is, according to the definition, we're going to say the reverse of the tail plus the head. So the head is simply A over here, plus, and the reverse of. Okay, so it's going to be the reverse of. Let me just move a little bit more space over here. The reverse of B, C, and D. Okay, like that, right? Reverse of this, and then plus the A at the end over here. And to execute this recursive call, reverse of BCD, we have to follow the same decomposition strategy over here, right? We're going to decompose that into B and also the rest, the tail. Let's now do that. So it's going to be B followed by the tail. Let me use orange over here, right? CD, right? And let's now try to see how to execute this recursive call. And we are talking about just this call over here, right? Don't forget, we still got plus 8 at the end. Okay, so this part over here, and by the way, so this is reverse of that we started with, right? Don't forget. So we're gonna put the B over here at the end, right? So the B over here is going to be placed at the end, and plus this part over here will just be a recursive call of the tail, and the tail will just be CD. So it's going to be reverse of. Okay, let me make some space over here. Reverse of CD. Okay, like that. One thing to note, you can see the plus B comes from this second recursive call over here, and the plus A comes from the original call for the reverse of. Just don't get confused. Okay, and let's now take a look at how we handle this second recursive call, which would be on CD. So now, in order to do that, we gotta decompose that from C and then the rest, which will just be D. All right, let's now take a look. So C over here, the head over here. What about the tail? The tail will be, in this case, just a single character, which means we're gonna reach the base case very soon. Let me use a different color here. How about purple? Okay, so this will be the tail for the string over here, right? And let's now try to see what this recursive call will be executed. So let me just go back to the blue here. So this part over here is going to be like here. The last character will just the first character will just be C. So C plus, right? And then what about the tail? the tail is simply just the D over here. So in that case, it's going to be the reverse of D. Okay, let me make some space over here. It's going to be the reverse of D. All right. What's going to be the reverse of D? You can see reverse of D. The D here is only a single character string. In that case, it will reach this particular base case. In that case, it's simply going to return just the string itself, right? And we are actually, well, as soon as we are reaching the base case, that means that we're almost done. We're halfway through. So now just going to be a series of return from the call stack. So this part over here is simply just going to return just the D itself, right? After this, we're going to go back to this particular call over here. We already, we're going to go back to resuming this particular recursive call, reverse of CD. So this C is here, and also reverse of D, we know that it's already D. So D plus C is going to give us DC, right? So that one there is going to give us DC. And that means this part here is going to be replaced by DC. And then we're going to say DC plus B in order to calculate the reverse of this, right? So DC plus B going to be DCB. Okay, so that one there is going to be DCB, and that'll be the pink one. Okay, so this one here is going to be replaced by DCB. So DCB over here, DC concatenated with B. And finally, to really calculate DCB plus A, in that case, we can calculate the reverse of, which is the original problem. So DCB plus A is going to give us DCBA. Okay, so that will be the final one. So that means that will be replaced by DCBA, right? One thing to note, if you see this, what we said originally is to say A will be at the end, and also the reverse of BCD, right? You can see eventually when we return up to this point, the reverse of BCD is exactly DCB, right? This is where the magic actually occurs. But it's, again, this is really no magic. If you really actually try to trace, at least at a high level, you will see exactly how the reverse of the string will be constructed right from the bottom of the base case, and then gradually get concatenated with the first character of the original string, right? That's what we will get. All right, so I think this one might be slightly more challenging for you to actually understand than the palindrome, but I hope it's still acceptable. All right, study this very carefully, and then if you really want, you can feel free to actually use the call stack and try to trace it. But I would say this one might be easier for you to understand, at least not to lose the big picture. All right, let's now go back to the slides, and that will be the lines of code about reverse of that we just went through. Right, let's now move on to the third and last example for recursions on strings.